All right, let's get into it. Today, we're going to talk about two of the best problems you can possibly have with a successful application. First, what do you do when you have way too much data for just one database? And second, how do you change that database later without shutting the whole thing down? Okay, let's dive in.
So, picture this. Your Go application is a hit. I mean, it is really taking off. Users are signing up like crazy, data is pouring in, and that smooth, snappy experience you built, well, it starts to chug. This is what we call a good problem to have, but make no mistake, it's still a huge problem. The very success you were hoping for is now pushing your architecture to its breaking point.
And 9 times out of 10, you know who the culprit is? Yep, it's the database. A single database, no matter how beefy the server it's on, can only handle so much. It's got limits on connections, on queries, on the amount of data it can sift through. Pretty soon, it becomes the single point of failure, the bottleneck that makes everything slow down for everyone.
Now, when you hit this wall, and you will hit it, your first instinct might be to just throw more money at it, right? Buy a bigger server. We call that scaling up. But you can't do that forever. The real sustainable solution is to start scaling out. And for a database, that means we have to split it up. This brings us to a fundamental concept in system design, sharding.
So what on earth is a shard? The classic analogy is perfect here. Imagine you have this ridiculously huge 1,000-page phone book. It's a nightmare to search through. Sharding is like ripping that giant book into 26 smaller, more manageable books. One for A, one for B, and so on. Each of those smaller books is a shard. It's a totally separate, independent database that just holds a piece of the total data.
It sounds simple, but this is an absolute game changer. Instead of one giant, monolithic database that's sweating, trying to do everything for everyone, you break it apart. You partition that single system into multiple, smaller, independent databases. Each one is a shard, and when you put them all together, they can handle way more traffic than that original one ever could.
Okay, so there are basically two main flavors of sharding. The one you're going to see 99% of the time is horizontal sharding. This is where you split your data by rows. You could say all users from North America go to shard 1 and all users from Europe go to shard 2. Simple. Vertical sharding is a little different. Here, you're splitting a table by its columns. Maybe all the critical user profile info, name, email, goes on a super fast server, while things like user-uploaded photos or logs go on a cheaper, slower one. It's all about splitting the data based on how you use it. So, is all this hassle actually worth it? Oh, absolutely. The benefits are massive. For scalability, it's incredible. Need more capacity? You just add another shard. It's that simple. For performance, your queries are suddenly lightning fast because they're hitting smaller databases. And in the Go world, this is where incredible tools like Vitis, which actually came out of YouTube to solve this exact problem, come into play to manage all this complexity for you. And finally, just managing the things like backups and maintenance becomes so much easier. This quote just perfectly nails our next challenge. Okay, so you did it. You've sharded your database, your app is absolutely flying. But then the product manager comes over. We need a new feature, and that feature means you have to change the database schema. How do you possibly perform open-heart surgery on this complex system while it's live and serving millions of users?
And that, my friends, is the migration dilemma. The goals here are crystal clear, and honestly, they're non-negotiable for any serious application. We're talking zero downtime for your users, and 100% data integrity. You mess up either of those, and you failed, period.
Now, the simplest approach is something called the Big Bang migration. You put up a maintenance page, take the whole app offline, run your database scripts, deploy the new code, and pray everything comes back up. It's like shutting down the entire interstate highway system at rush hour, just to repaint some lines. It's simple to think about, but the downtime is a killer, and if anything goes wrong, well, it's a catastrophe.
So how do the pros do it? How do places like Google or Netflix handle this? Well, they use a strategy that's as elegant as it is safe, often called the expand/contract pattern. And the best way to think about it is this. You don't shut down the old rickety bridge. Nope. You build a brand new, shiny 8-lane bridge right next to it. You slowly move traffic over, and only when you're sure the new one is rock solid do you even think about tearing the old one down.
It all happens in 3 really careful phases. First up, expand. In this phase, you only add things, you never delete. You add your new columns, you add your new tables, then you deploy your new Go code. And this is the crucial part. It writes to both the old location and the new location. This dual write is the absolute key to the whole operation. All the while, the application is still reading from the old trusted schema.
All right, phase 2, migrate. This is where the heavy lifting happens. First, you run a background job, maybe a simple Go worker, to copy all of your old historical data from the old schema over to the new one. Once that's totally finished, you deploy another code change. Now your application starts reading from the new schema. The dual writes are still happening, so the old schema is basically a live, real-time backup ready for you to switch back to in an instant if anything looks weird.
And finally, after you've triple-checked your dashboards, you've let it run for a while, and you're absolutely positive everything is rock solid, then, and only then, do you move to the contract phase. You deploy one more piece of code that turns off the dual write. Now you're only running to the new schema, and after that, you can finally run a script to drop those old tables and columns. It's methodical, it's incremental, and most importantly, it's safe.
Now you might be thinking, isn't there another way? And yes, there is. It's a popular strategy called blue-green deployment. You basically build an entire identical copy of your production environment. We'll call it green. You get it all ready with the new code and the new database schema. Then you just flip a switch at the router level and all your traffic instantly goes to the new green environment. The big win? Instant rollback. If anything is wrong, you just flip the switch back to blue. The catch? And it's a big one, it costs a fortune because you're running double the infrastructure, and keeping the data in sync between the two can be a massive headache.
And this is where we kind of zoom out from the how and start thinking about the why. It's the difference between a junior and a senior engineer, right? A junior engineer asks, what's the best way to do this? A senior engineer asks, what are the trade-offs? There's no single best answer for everything. There's only the best answer for your team, your app, your budget, and your appetite for risk.
And this table really just sums it all up, doesn't it? Big Bang is simple and cheap, but you pay for it with high risk and downtime. Blue-green is super safe, almost zero risk, but wow, is it expensive and complex. And right there in the middle, you see the expand contract pattern. It hits that sweet spot for most of us, zero downtime, low risk, and a level of complexity that's totally manageable.
You know, when you boil it all down, this isn't just about databases or code, it's about a fundamental philosophy. Great engineering isn't about building something that just works today. It's about building systems that are designed to evolve safely tomorrow. Sharding prepares you for data growth, safe migration patterns prepare you for feature growth. You are literally architecting for change itself.
So I'll leave you with this one question to think about for your own work, for your own projects. Is the system you're building right now designed to scale, or is it designed to break? Because the architectural choices you make today will absolutely determine that answer down the road. Thanks for watching.